All right, class, come on in, get ready, get out your CJs. I'm coming around the check in just a second. Where's my red pen? Oh, here it is. I love my red pen. Anyway, hey, go ahead and get out your notebook. We're going to start your do now.
Okay, Mr. Mazan.
Self, get going. Flufflepuff, hurry up.
Mr. Mazan, can I go get my notebook?
Yes, you can go get your notebook from your locker. You're supposed to bring it, but go get it. Anyway, if anyone doesn't have their stuff, just go get it now.
Mr. Mazan, he took my pen.
Stop messing with her, Self. Self, why are you taking her pen? Oh, you didn't bring your own pen. Or you're supposed to bring a pencil anyway to math because sometimes people make mistakes. I've already warned you once in the hallway. You were playing around and you should have been getting your pencil. Now you're going to see Miss Weisberg. You need to bring a pencil yourself. Don't rely on Flufflepuff every day. You need to bring one yourself. Okay, yeah, you're going to see Miss Weisberg. All right, maybe you can figure it out. When you're good, we'll be happy to have you in class. Oh, good. Here's Mrs. Weisberg now. Miss Weisberg?
Yes?
I've warned him. I've already put a sticker in his CJ. Self has been stealing pens because he did not bring one himself. And I've already warned him, put it in a CJ, so...
Self, we've talked about being accountable in the classroom and coming prepared to class. Now we really need to go down to the office and talk about this some more.
Okay, I'm sorry.
Self, we've talked about this before. You need to stop taking pencils from other people. That's called stealing, and that's against the school code of conduct. You need to start holding yourself accountable.
I thought it was mine, though. I had one just like it.
Really? That's what you said last week when you took pencils. From Jim.
Oh, yeah. Well, maybe it was hers. I just thought it was mine, kind of. Maybe it wasn't.
But now you realize that the pencil was not, in fact, yours, correct?
Yeah.
So what are we going to do about this? How are you going to make this right?
Well, I just need to be... My mom bought me some. I just always forget.
So I think it would be a good idea for you to bring those pencils to school and to give new pencils to those who you took pencils from before.
Okay, I'll be good.
Yeah, I really want you to get back to that parallelogram lesson.
I like parallelograms.
Me too, they're fun. Oh, and
Can I go get my ball, though? It's really...
yeah, where did you find the ball? Where did you throw the ball again?
It's on the roof! The roof!
Bye.
All right, let's go ahead and go over this lesson, parallelograms. The first thing I want to talk about is this line right here. Let's say from A to B, these are segments. Line, remember, goes forever in opposite directions. Okay, but we can name certain parts of the line called segments. So segment A to B, let's say, is equal to 7 inches. And then from A all the way to C is going to be equal to, use both lines, so put a line above them. Let's say that's equal to 18 inches. Okay? So if you want to find this distance right here, you take the whole distance, which is line AC, and you subtract line AB, and that gives you what's left over. It's kind of like if there's 10 people in a class and the 4 boys go outside to play, what's left over? They're the girls. There's 6 girls. Okay? So you basically just take 18, subtract that part of the line, and you're going to get 11 inches. So line AC, or BC, I should say, line BC is going to be equal to 11 inches. Now, we're going to do something here. But I want you to keep the concept in mind. You take the whole thing, you subtract part of it, and then you have what's left over. Now let's say this is point A, point B, C, D. All right? So we know that angles that are next to each other, I'll say like shoulder partners, so angle A and B are shoulder partners, they're right next to each other, they both equal, when you add them up together, they equal 180 degrees. Kind of like segment AB and segment BC, when you add those together, they equal 18 inches. Well, when you add angle A and angle B, when you add those together, you're going to have 180 degrees. Okay? Now, let's say the problem gives you this angle right here. Let's say it's 67 degrees. Angle B is 67 degrees. Well, we know that in all parallelograms, that if you have two angles that are adjacent is a fancy word, it just means they're shoulder partners, okay? They're right next to each other. Two angles that are adjacent, they add up to 180. All of them together is 180. Just like this whole line together is 18. Well, those two are 180, and I know that part of it is 67. I don't know angle A yet, but if I subtract angle B, which is 67, you can borrow from that. You're going to get the angle A is 113 degrees. Okay? And that is angle A. Angle A. Okay? So, that is true for all parallelograms. Now, the other thing is angles that are opposite each other are also equal. So now we have all the angles of this parallelogram. So this is 113. How do I know? Well, it's opposite angle A. So now we have angle D is equal to 113 as well. And then angle C, we have that because that is opposite angle B. So we have angle C is equal to 67 degrees. All right. So here's a little, I don't know why I'm doing this one, but this is just to drive home the point. That's point E, F, G. All right, so if we know that this is 90 degrees, that means we know that this is also 90 degrees. And then you can say, oh, well, those two are adjacent, so I can take 180 minus 90. Oh, and what do you have? 90 degrees. That means the adjacent angles are also 90 degrees. All right, so there's a little bit on parallelograms. Let's do area of parallelograms next. All right, before we do area of parallelograms, I want you guys to practice. In a second, I'm going to have you guys pause this video. It'll be just like we do whiteboard guided practice, okay? But right now, when I say pause, not yet, not until I say go, when you pause it, I want you to work this out on your own. Then unpause the video and I'll work through it and you see if you get it right. Now some people say, well, why can't I just let the video keep running? Listen to me right now. This is important. You have to practice something without me just giving you the answer. It's like if you were working out, if you got on a bench press and you're lifting a bench press or something and the guy behind you who's spotting you just lifts it for you. Are you getting any stronger? No, you have to struggle with the weight yourself in order to get stronger. That's how you get better at something. So in a second, I'm going to have you pause this. You're going to struggle and try the problem by yourself and then unpause it and the answer will be there. Okay? And you can see if you got it right. Ready? Pause. Now, I'm going to show you the answer. All right, so I know that X, and I should name this one too. I'll name it, let's say M for Maison. Okay? X and M are adjacent. They're shoulder partners. Okay? So that means that they add up to equal 180 with each other. So I'm going to do some scratch work. 180, that's both of those angles together. And if I subtract the one I know, 57, I know how many degrees are left. And that will be the measure of X. Okay, so let's borrow from that. 10, that'll be 3, 7 minus 5 is 2. So that'll be 123 degrees. Then I know angle Z is also 123 degrees because it is opposite of X. And I know that Y is opposite M, so that will be 57 degrees. Okay, now we're going to do area of parallel. All right, so we have a parallelogram and we're going to find the area. That means how much area or room do we have inside here if we were carpeting, if there was a room that was this shape, and how much carpet could we fit on that room? How many squares of carpet? Well, you simply take area is going to be equal to the base times the height. Now, how do you know base and height? There's two numbers that I need to sub in there in order to find what the area is equal to. But I have three numbers up here. How do I know which of these three to put in these two slots? Well, you simply look for the, what is it? The 90-degree angle. And I'll do this in red. Right here, guys. So the sides of the parallelogram, or the parts of the parallelogram that are adjacent to that 90-degree angle, those are the parts that you use. Well, 9, of course, is right next to the 90-degree angle, so I'll make that my base. And then 4 is the height. That's right next to the 90-degree angle, so I'm going to use that as my height. So I don't need this, unless I'm finding perimeter, which is distance around, different than area. So I multiply those two. 9 times 4 is going to be 36 inches squared. Don't forget the square. All right, I'm going to have you try one. All right, here's yours. Area equals base times height. 6 is the bottom, the side is 8, and then from there to there is 5. And pause. All right, I'm back. Now I'm going to show you how to do it. It's basically the 90-degree angle is there. So 6 times 5. 6 and 5 are your base and height. They're going to equal your area. 6 times 5 is 30 inches squared. All right, sometimes you'll see parallelograms look like this. And you'll see, wait, there's a 90-degree angle. Oh yeah, there is. It's out here. So if there's a 90-degree angle out here, then we got that 90-degree angle is definitely not adjacent to this one, but it is adjacent to the 4, so your area is going to be equal to base times height, and 4 can be your height. And what's our base? Well, 6 is kind of close to there. It's as if this line right here, if I were to draw an imaginary line there, that one would be 90 degrees. And this imaginary line and this imaginary line, both would be equal to each other, congruent. So 4, that would be 4, and then our base would be 6. So and this 6 right here is kind of adjacent, kind of shoulder partners with that 90-degree angle. So you're basically taking 6 times 4, which is 24 inches squared.